So if you're not familiar with health IT standards, you may be wondering, why have we such issues in the first place? Why are we stuck in a point-to-point transactional standards environment? And essentially, this is a case of being too far ahead of our time. The US started using HL7 version 2.0 in 1988, the previous version 1.0 being somewhat of an experimental pilot study type of thing. And today we use versions 2.5 through 2.7. The 2.7 was published in 2011. These are all, as I said before, point-to-point standards. HL7 developed a version 3 in 2005. It supports a service-oriented architecture that enables web services and is being used by both U.S. and other country vendors to supply systems to entities outside of the United States who started adopting EHRs later than the U.S. But for the U.S. to move to HL7 version 3 that supports that many-to-many exchange, the web in other words, is not backward compatible with the version 2 point whatever, 5, 6, 7, we call it 2.x. Retooling virtually all systems would be necessary to adopt version 3, with a price tag that is many times greater than the price of EHR systems alone, which have run upwards of several $billions in some cases. So what to do? In 2001, HL7's Clinical Document Architecture, CDA, was introduced to enable exchange of documents in either HL7 version 2.x or version 3, potentially paving the way for more use of HL7 version 3. In 2011, the Office of the National Coordinator for Health IT adopted the CDA, Clinical Document Architecture, in the form of the Continuity of Care Record, CCR, which was developed by the ASTM International Standards Development Organization, which was also combined with the HL7 Clinical Document Architecture, and then was called the Continuity of Care Document. This was, as I said, adopted in the Meaningful Use program in 2011. In 2014, ONC adopted the Consolidated CDA, or CCDA, for the Meaningful Use program. The CCDA is a set of templates for different types of documents. But HL7 version 3 still did not take hold despite this effort. It was just too costly to retool every system. Still, researchers persisted in finding a way to overcome the HL7 version 2.x and web services conundrum. In 2012, one set of researchers introduced the HL7 Fast Healthcare Interoperability Resources, referred to as FHIR, F-H-I-R, which is a framework built upon a set of modular components called resources, which appears promising, though still not widely adopted. In 2017, ONC has proposed to adopt this for future use. Let's explore these two new options from HL7 a bit further. The Clinical Document Architecture, or CDA, from HL7 provides an exchange model for clinical documents such as discharge summaries and progress notes. It utilizes a document markup specification, XML, the extensible markup language, providing for persistence, stewardship, potential for authentication, wholeness, and is human readable. It also leverages the use of the HL7 Reference Information Model, or RIM. Coded vocabularies, which we're going to talk about next, under semantic interoperability, and the LOINC attachment type codes, also to be discussed in semantic interoperability section. The CDA is intended to make documents both machine readable, so data are easily parsed and processed electronically, and human readable, so they can be easily retrieved and used by the people who need to see them. A CDA may be transmitted within an HL7 version 3 message or as an attachment to an HL7 version 2.x message. We'll see what this looks like in the next slide. The CDA specification defines a multi-level architecture where each level is derived from a more basic level. Levels refer to varying degrees of required markup granularity and specificity. So, for example, a patient summary document using the data content from the ASTM International Standards Development Organization, as I mentioned in the last slide, called the Continuity of Care Record Standard, can be sent as an attachment to an HL7 version 2.x message. Once the document is received, it can be viewed and or printed. But basically, it is just a general document specification. The next level of granularity, level 2, enables specifying the type of document, so it can be identified that a document is an operative report, discharge summary, or whatever. The Consolidated Clinical Document Architecture, CCDA, is a set of templates to make use of the CDA at level 2. It essentially provides a constrained set of structures and semantics based on LOINC document type codes. The most granular level 3 format is expressed as an XML document with additional markup, enabling content to be expressed formally following the reference information model from HL7 and is used within HL7 version 3, and depending on the level of tagging, the tags associated with each of the markup specifications can produce structured data. Multiple challenges exist with CDA, most notably the fact that it focused primarily on creating documents, not structured data, meant that there was no ability to query or interpret unique data elements in most of its uses, which were limited to level 1 and level 2, which could be accommodated by HL7 version 2.x. Second, there was considerable confusion by implementers in how to use the various characteristics of the CDA, so the documents exchanged often contained the right data but in an illogical manner. Most importantly was that there was no official standard application programming interface or API for requesting documents from a source system. And we'll talk about this a little bit more later. This slide on transmission of CDA illustrates what an HL7 version 2.x message looks like. So there's the message header, the event, the patient identifier, etc., and then an OBX segment, which we said was an observation segment, that basically says, in this example, there is one attachment and it is an emergency department report. This then essentially references the CDA as an attachment. This slide also illustrates how this emergency department report as a CDA can be incorporated directly into an HL7 version 3 message in XML format. In this case, you can see that there's some of the, obviously the message would be a lot longer, but there's a service code and it indicates that there was an emergency department set of information. The CDA is embedded right there in the XML format, and then closing off that code indicates that the document is complete. To overcome the challenges in using the CDA, as I said before, several researchers began creating new approaches to interoperability within an HL7, what they called Fresh Look Task Force. The result of the Fresh Look Task Force was the creation of the Fast Healthcare Interoperability Resources, or FHIR, that represents clinical data as resources, where each resource is an expression of meaning using well-defined fields and data types. FHIR's foundation is in web standards, so the user sees the information coming into their computer, much as we see a browser bringing all sorts of information to us on our computer. The FHIR uses XML. It uses JSON, or the JavaScript object notation. It uses the Hypertext Transfer Protocol, HTTP. It uses the OAuth, which is an open standard for authorization developed by the Internet Engineering Task Force, which is basically the standards development organization for the Internet, and other web services standards. So it is really very compatible with the web and really with many other organizations and entities even outside of healthcare, should we need to exchange data in such a way. FHIR enables application programming interfaces, or APIs, from each healthcare information systems vendor to communicate with each other. So I can send a message that I have in HL7 version 2.x, for example, in vendor A. I can send this message to a system created by vendor B, perhaps in another state or whatever, and each of those vendors adopt the same application programming interface to enable that exchange to occur. In so doing, it supports RESTful architectures, seamless exchange of information using messages or documents, so structured data or narrative data, and service-based architecture. I want to pause here for just a moment and talk a little bit more about REST. The representational state transfer, or REST, allows systems to access and manipulate textual representations of resources, in this case defined via FHIR, using a uniform and predefined set of operations. However, I do want to mention that other forms of web services exist. Not everything is RESTful. For example, WSDL and SOAP are very common. WSDL, or the Web Services Description Language, is an XML-based interface language that describes the function of a web service. SOAP, or the Simple Object Access Protocol, is a specification for exchanging structured information via web services or even internal computer networks that don't normally talk to one another. Now, I mention this because while HL7, with its clinical document and data exchange focus in healthcare, has created FHIR and supports REST, it is somewhat frustrating that health plans have been adopting operating rules that focus on the use of WSDL and SOAP. So here again, another interoperability conundrum. In addition to FHIR, researchers from Harvard Medical School and Boston Children's Hospital, with funding from the ONC, have created an interoperability project with the goal of developing a platform to enable all medical applications to be written once and run unmodified across different healthcare IT systems. This is really, truly the vision of interoperability. The project was called Substitutable Medical Applications and Reusable Technologies, or SMART. When SMART and FIRE are used together, which we call SMART on FIRE, health apps can connect to EHR systems with appropriate security guarantees, including appropriate authorization, authentication, and user interface integration. Since this work began, other researchers have started creating apps for smartphones using Smart on Fire that are medical apps that integrate with EHRs. For example, the Duke Pillbox app was created at Duke University for their patients to manage their medication administration.